Hi, welcome back. This is video number 2 for lesson 4.1 for Algebra 2. Let's talk about minimum and maximum values of quadratics in standard form. So for y equals ax squared plus bx plus c, the vertex's y coordinate is the minimum value of the function if a is greater than 0 and the maximum value if a is less than 0. So remember, minimum and maximum refer to function values. So it's always going to be a y value that we're interested in. So it's going to be the y value of the vertex, but you need to have it separate in your mind that the vertex is the point, both the x and the y. The maximum or minimum is just the y value. Okay, so when a is greater than 0, when a is positive, the graph looks like it's smiling at you. And so, as you can see, when it's upward opening, there is a minimum y value. The y values start at the minimum and then get bigger and bigger. When a is less than 0, when a is negative, the whole thing is frowning at you. And so there is a maximum there. There is a y value where the function peaks, almost like a mountain, looks kind of like a mountain. It peaks there and then goes back down. So minimum if a is positive, maximum if a is negative. Unless stated otherwise, the domain of a quadratic function is all real numbers. You can plug in anything you want for x. Depending on the sign of a, the range will either be all real numbers greater than or equal to the minimum value, or all real numbers less than or equal to the maximum value. So for the minimum value here, when you have a minimum, so when a is positive, that minimum value is going to be where your y values start and get larger. When a is negative, the maximum value is going to be where the y values max out. Okay, the y values are going to come up from what we call negative infinity from that direction and then max out at that maximum value and then go back down. All right, so for example 4, we're going to tell whether the function y equals 3x squared minus 18x plus 20 has a minimum value or a maximum value. Then find the minimum or maximum value. So there's two parts to your answer. You need to state whether you have a maximum or minimum and then what that actual value is, that minimum or maximum y value. All right, a is positive. Okay, it's greater than 0. It's positive, so the whole thing's going to be smiling at you. And so there's going to be a minimum value. It's going to look like a valley, and there's going to be the bottom of the valley. Okay, so to find it, calculate the coordinates of the vertex. You want the y value. We're going to go ahead and calculate. Here's a picture. We're going to actually talk about finding minimums or maximums on your calculator in just a minute. To get that x coordinate, you do x equals negative b over 2a. So negative, and then b is negative 18 over 2 times 3. So negative 18 divided by 6 is negative 3. Negative 3 is positive 3. And to get the y value when working by hand, because remember, you will have a non-calculator part to your test, and you're probably going to have to find minimums or maximums without using your calculator. So you need to know how to do this by hand. All right, anytime you have an x value and you want to know the coordinating y value, you just plug it in. So we're going to plug in 3 everywhere we see x. So we're going to have y equals 3 times 3 squared minus 18 times 3 plus 20 equals negative 7. How did we get negative 7? Well, 3 squared is 9 times 3 is 27. 18 times 3 is 54, so 27 minus 54 is negative 27 plus 20 equals negative 7. So we have a minimum function value of negative 7. The minimum value is y equals negative 7. You can check the answer on a graphing calculator. But remember, you need to know how to do this by hand because it's going to be on the non-calculator part of your test. Now, some of you may be going, okay, well, if the answer is just the negative 7, if it's just the y value, why did we have to find the x coordinate? Well, you have to find the x coordinate so you can generate the y coordinate. So that's why we have to find the x coordinate first. Okay, so take some notes on this. We're going to find finding extreme values. That's a way of saying maximums and minimums with the CAS. What you want to do is you want to enter the equation in F1 in the graph portion of your scratch pad. Okay. Now, If your scratch pad has a bunch of stuff in it, especially on the graph part, remember to dock B it, and that will clear everything out. Okay, so here is a screenshot of my calculator where I have entered the function in F1. I haven't hit enter yet. I've just typed it in. Once I hit enter or press enter, I get a picture of my function. Okay, so there it is. I can look at it. You want to make sure you can see the maximum or the minimum. Now I'm looking at this. I can see it. I can see that this opens up. That makes sense because A is positive 3. I can see that I would have a minimum value because it does look like a smile or like a valley. And so we would get, the minimum is going to be at the bottom of the valley. So I determined whether I have a max or a min. I have a minimum in this case. And this is really important because you're going to have to tell the calculator whether you want it to look for a minimum or a maximum. So I just typed in the minimum there. It's not something that's going to show up on your calculator. I don't want you to be confused about that. All right, so go to Menu, select Analyze Graph, and then minimum, a maximum or minimum, depending on what you need. We need minimum. Okay, so at that point, your screen should look like this. They should be asking you for a lower bound. Now, lower bound just means left. So you're going to find a lower bound. You're going to find some point you're happy with that's to the left of the minimum. Okay, visually, we can see here where the minimum is. So I could just press enter here because that's to the left. Or I could come over here and pick a place closer to my minimum, but still to the left of it. And then it'll ask me for upper bound, and I'll move to the right of my minimum and I'll press enter again. And then it's going to give me down here, it's going to give me the value, actually it's going to give me the coordinates of my vertex. I have to look at that and go, oh, okay, -7, that's my y value, that's the actual minimum. Okay, so the calculator gives you both coordinates. You want the y value, the minimum is -7. Note that I had to adjust my window to see the coordinates. If you look back at the previous slides, I just had the standard window where the y minimum was -7.39 and the maximum was 7.39. Even though I can visually see where the minimum is going to be on this, when I find it, I couldn't read what the coordinates were. So I went to Window, I went to Menu, and then Window, and I adjusted manually the minimum for the y values and the maximum for the y values to -15 to 15 so that I had more room and I could see what the coordinates of my minimum value of my function is. Okay, example 5, go-karts. A go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there would be 20 more racers per week for every $1 reduction in the price. When you put things on sale, more people come. Okay, in the price per racer. Okay, how can the owner of the go-kart track maximize weekly revenue? All right, let's define the variables. Let X represent the price reduction and R of X represent the weekly revenue. We're going to write a verbal model and then write and simplify a quadratic function. So revenue, R of X, equals the price, so $35 minus however many dollars you're going to put it on sale, times the attendance. So it's going to be 380. The number of people you have when you charge $35 plus 20 times X. Because remember, for every $1, he expects 20 more people to show up. All right, so we FOIL, and we get 35 times 380 is 13,300, plus 35 times 20 is 700X, minus 380X, and then minus 20X squared. So let's put that in standard form, the ax squared plus bx plus c form, because if you don't do that, it's real easy to mess up what a equals, what b equals, and what c equals. So a equals -20, b equals 320, and c equals 13,300. So we're going to find the coordinates of the vertex. So x is -b over 2a, so it's -320 over 2 times -20. And so that gives us 8. Okay. So what that's saying is, to maximize the revenue, the price needs to be reduced by $8. Remember, X is the reduction in the price. So we need to reduce the price by $8. Well, how much revenue will that give us? Let's check. We're going to evaluate the revenue when the price is reduced by $8, so R of 8. And so we plug in 8 everywhere we have X. So negative 20 times 8 squared plus 320 times 8 plus 13,300 simplifies to be 14,580. So the vertex is 14,580, which means the owner should reduce the price per racer by $8 to increase the weekly revenue to $14,580. Okay, guys, that's it. That's the last example. You've got some problems to try on your own there. So try those problems on your own. We've learned all about functions, quadratic functions in standard form, the y equals ax squared plus bx plus c. We learned that you have a vertex where the x-coordinate is negative b over 2a. An axis of symmetry is going to run through it there, and so it'll have an equation x equals negative b over 2a. And we learned that the y-intercept is 0c. We learned that if a is positive, you have a function that opens up and it has a minimum function value. We learned if a is negative, you have a function that opens down and has a maximum function value. So we've learned a lot of really important information. So make sure you try those problems to try on your own and come to class ready to go. All right, I will see you in a day or two.